So what about sigfigs? We learned about sigfigs last week. We need to understand what happens with significant figures and unit conversions. English conversions, that means from one English unit to another English unit, or metric from one metric unit to another metric unit. Those factors are always exact because the units in the English system are defined by other English units. So 1 foot is exactly 12 inches. There's no uncertainty. We set it up that way. 1 gallon is exactly 4 quarts. 1 kilometer is exactly 1,000 or 10 to the 3 meters. So these factors, because they are within the same system, you just ignore them when you look at the significant figures. They do not affect the significant digits of the result. Okay? Exact numbers also do not limit the number of significant figures. So counting numbers, like if you're starting out with a number like 28 students, that's a number that you can count. There's no uncertainty in that. So that won't affect significant figures. Exact conversions, like within the English system, and the number 1 in any conversion. Most conversions are set up so that one something equals a number of the other thing. The 1 is understood to be exact. If we relate metric units to English units, that involves measurement, and those unit conversions are not exact. So a pound is 454 grams. That looks like an exact number because it's a whole number, but it is not. Can we figure it out to more significant figures? Sure we can. And if you look in the right places, you could probably find it to 7 or 8 decimal places. Do we need to do that all the time? No, and so we often use approximations. So in the slides here, you'll see a lot of this is approximately equal to. In the textbook, in the table of conversion factors, it says equal. You need to understand, though, that between metric and English system, it's not exactly equal. A quart is approximately 0.9463 liters. So these ones are exact, but this conversion factor, this unit factor, is going to limit your result to 3 significant figures. This one will limit it to 4. So we do have to include those guys. There is one exact metric English conversion, and that involves inches and centimeters. So here, 1 inch, this triple line is a fancy equal sign, meaning exactly equal to, the same as. So 1 inch is exactly equal to 2.54 centimeters. So this does not limit your answer to 3 significant figures. This one is exact because we redefined the inch in 1958 to be exactly 2.54 centimeters. Okay? So let's do some of these conversions. The length of an American football field, including the end zone, is measured to be 120 yards. What is the length in meters? So what are they asking for? Meters. And what do they give us to start with? Yards. 120 yards. How many yards in a meter, or how many meters in a yard? Does anybody know? 0.9144, thank you. 0.9144 yards equals 1 meter. A meter is about 39 inches. It's roughly the same as a yard, but it's not the same. Because we were able to find a conversion factor, a unit equation that relates these two things directly, we can go directly from one to the other. Now, if you did not have access to something like that, you might have to rely on what you can remember. And so there are many other ways you can get from point A to point B, just like there are many ways to get from Reedley to Fresno City College. Some are more interesting than others, and some are faster. You could go yards to feet to inches, and inches to centimeters, because I happen to remember 1 inch is 2.54 centimeters, and then from centimeters to meters. Would it work? Yes. It's more work than this one, so we're going to use this because we have it. So 120 yards, and the map says yards to meters, so we're going to put meter on the top, and we're going to put yard in the bottom because these guys need to cancel out. We look at our unit equation, and we see 1 meter is equal to 0.9144 yards. Then we get out our calculator, and we take 120 and divide by 0.9144. And my calculator gives me this big old mess. 131.233 596 meters. That's a ridiculous amount of digits, isn't it? Well, this number, 120 yards, how many sigfigs? We get disagreement, 3 or 2? 2. This is an ambiguous 0. Now, is the football field measured to the nearest yard? Yeah, it probably is, right? They've got, they actually draw stripes on it, right? So if they meant that, then they should have put a decimal point after that. But it was written 120 without any decimal point, so we have to assume the worst about this number and say that it's just to the nearest 10 yards. So 2 sigfigs in that number. This is not an exact conversion factor, unit factor, because we're going between metric and English. So this one has 4 significant figures. And so the smaller one is how many we have in our answer. And so this is going to be 130 meters. That is not the best way to write it. It would be better to write 1.3 times 10 to the 2 meters, because then we get rid of that ambiguous 0. Any questions? The 1 in the conversion factor is exact. The other unit is not, the other number. I have numbers and units completely confused today. A half-gallon carton contains 64.0 fluid ounces of milk. How many milliliters of milk are in a carton? What unit are they asking for? Milliliters. And what unit do they give us? Fluid ounces. 64.0 fluid ounces. Because there's also weight ounces. And those are different. Anybody know the relationship between fluid ounces and milliliters? I think it's 355 milliliters is equal to 12 ounces. Anybody have a can of soda? It's on the can of soda. It gives the volume in milliliters and in ounces. 946 milliliters per quart? Okay, that works. 32 ounces in a quart. We better stick with our fluid ounces. When you're doing these things, you have to use what's available. On a test, you would be given unit equations that would be sufficient to do this. These are not things I would expect you to memorize. I don't have these memorized. So fluid ounces, knowing these two things, we can convert fluid ounces to quarts, right? So we could go to quarts. And then we have this relationship between quarts and milliliters. So we could go from there to there. Any questions about how I made the map? It's a little bit like crossing a creek and there's stepping stones. This creek is too large to jump across in one leap. And so we need to find a stepping stone in the middle that we can step on to get to the other side. And so here it happens to be quartz. So 64, I don't know where that came from. 64 fluid ounces. I have 2 conversion factors. I have 2 arrows. I'm going to have 2 unit factors. It's been a long week. Fluid ounces to quarts to milliliters. Fluid ounces to quarts to milliliters. Fluid ounces come down here so they can cancel out. Quarts come down here so they can cancel out. And then I put my units in. 946 goes with the milliliters. 946. And on the other side is 1 quart. 32 ounces and 1 quart. When you're doing these on your calculator, you don't need to write down intermediate values. When you write down stuff and punch it back into your calculator, every time you do that, you increase your chances of making a silly mistake. So all of these things, you can just type them straight into your calculator. The way we do that is we just go left to right, and you multiply by the top, and you divide by the bottom. Times the top, divide by the bottom, and you just go straight across like that, and then you press equals, and you're done. So 64 times 1 divided by 32 times 946 divided by 1 equals, calculator says 1892. The unit left is milliliters. We need to consider significant figures, though. This factor is relating an English unit to an English unit. So this is exact. We don't have to think about the sigfigs there. This is metric and English. We need to consider the significant figures. The 1 is understood to be exact, but 946 has 3 significant figures. That limits our answer to 3 significant figures. So you could call that 1890 milliliters. The problem is sometimes students forget to put the placeholder 0 in there. If you put it in scientific notation first and then round it, you don't have to worry about those placeholder zeros. So that's the best answer. This one's okay.
Can you repeat why I asked like how many significant figures?
Yeah. Repeat the significant figures thing. Well, I forgot to look at this. Our starting number had 3 significant figures. This unit equation, this unit factor, relates an English unit of quarts and an English unit of fluid ounces. When both of the units are from the same system, then significant figures don't matter because this is exact. Here we have a metric unit and an English unit. So this is not exact. And so we look at this and say that has 3 sigfigs. This one also has 3 sigfigs, and so our answer is going to have 3. Did that help?
Yeah.
Any other questions?
On the previous problem, I went the long way, 120 yards to meters.
Got a completely different answer. Interesting. It's possible that that conversion factor wasn't correct. Yeah. So in the previous problem with the yards and the, was it meters? Yards and meters. It's possible that if you do it a different way, it's going to come out different, because if our 0.9144 factor wasn't exactly correct, then that would mess everything up. So thank you. Any questions about this one? Yes?
You said 1890 would be okay.
Yes. Yeah. This has 3 significant figures. This is ambiguous. We want to avoid that, but I'm not going to mark that wrong. I'm just going to say that, well, that's not the best way to do it. The problem with something like that is there's probably about 25% of the students that are going to call it 189. And I can tell you it's silly, and you can agree with me that it's silly, but they're still going to do it. A couple more examples. Convert 14.10 pounds to centigrams. So centigram is what we're going for, and 14.10 pounds is what we have. Now we're being given a little bit of help here. Thank you. We have this relationship between pounds and grams. So when we're looking at this, we say, I don't know the relationship between pounds and centigrams. This is over here, maybe I should use it. That would allow us to go from pounds to grams. So let's try that. Can we go from grams to centigrams? Sure, that's a metric conversion. We just need to know what the prefix means. So there we have our path, our map. Now we can write our equation, 14.10 pounds. We have 2 factors because there are 2 arrows. So pounds to grams to centigrams. Pounds to grams to centigrams. The unit pound comes down here because we want those to cancel out, and grams comes down there to cancel out. Do all the units first, make them work, and then deal with numbers. So we need this guy. There's 454 in front of gram, so we're going to keep 454 with gram, and that's 1 pound. This metric conversion, we just need to know what centi means. 10 to the negative 2. So centi goes up here, and 10 to the minus 2 goes down here. Flashcards are a great way to learn the values of the metric prefixes. The other thing is when you need one, like here, try to remember it, and then look at the table and check yourself. That way you'll still get the right answer, but you'll have a little practice. So 14, let's get the calculator going, 14.1 times 454 divided by 1 EE minus 2. So I'm getting, the calculator is showing me 640,140 grams. Not grams, centigrams. And we have to think about sigfigs. Does this limit the number of sigfigs in our answer? No, because centigrams and grams are both metric, so we don't have to think about this one. How about grams to pounds? It does. The 1 is exact, but this has 3 significant figures. Our starting number had 4 significant figures, but our final can only have 3. We don't want to round that to 640, right? Because it's 640,000. When you round a number, you do not significantly change its value. So, best idea is to put it into scientific notation. The decimal point was here, 1, 2, 3, 4, 5 centigrams. And now if I round it off there, I don't have to worry about changing the value. 6.40 times 10 to the 5th centigrams. Any questions? Yes?
If you leave out the zero, would you have to include the zero?
We would not have to include the zero, and I thought about that as I did it. Didn't mean to do that. Here, that would not be considered a significant zero. I was a little sloppy because we were just rounding this, we were just putting this in scientific notation to round it. These digits aren't significant either, so I was kind of sloppy. You probably shouldn't put the zero in there, but it gets rounded off anyway. Anybody else? Let's do this other guy here. So we're trying to get to gallons. And we're starting with 3.88 times 10 to the 12th nanoliters. And this is what we have. Sometimes you start with your beginning unit and you work forward on the map, and sometimes you work backwards on the map, and sometimes you kind of have to do both. You do a little from the back and a little from the front until you figure out where you can meet up in the middle. This gives us a relationship between gallons and liters. So if I had liters here, I could get to gallons using that one. And then I've got this connection to make, and we can do nanoliters to liters because those are metric. So 3.88 times 10 to the 12 nanoliters, and then 2 fractions. Nanoliters to liters to gallons. Nanoliters come down here, liters come down there, units cancel out. It's learning a pattern. Do you see that? There's this pattern, and it works every time. It's beautiful. Sometimes it doesn't make sense to you right away. I remember a couple of girls in particular, it was like 4 weeks into the semester, and every day after class, they're asking me questions relating to unit analysis, and they just, they could come up with the right answer sometimes, but they just didn't know why. It didn't make a lot of sense, and then one day they came in and they said, "We get it. It's easy." And they were so excited, because once you get it, it is easy. Getting to that part can be hard. Don't give up, okay? If you've made it this far, you can do this. And please see me if you need help. So here's our number with liters. So do we want to put that with this liter or with this liter? This one over here, because this is the gallons to liters. So we want to keep those guys together. There's the 1 and 3.785. And then nanoliters, what does nano mean? Anybody? Nano sounds like 9. It's 10 to the negative 9. Nano, negative 9. 10 to the minus 9.
How come you wouldn't put it on bottom?
Good question. Why don't I put it on the bottom? I don't want to put it on the bottom because nano's on the bottom.
Yeah, but you said nano means negative 9, so.
Right, but nano is 10 to the minus 9. And so I have nano down here, and I have what it means up here. This is a little bit like a nickname for this number. So it's the nickname with the unit, the meaning with the unit. I have a son, most of my kids don't have nicknames really, but Tommy, his real name is Thomas. We never call him that. So there's Thomas Kawagoa or Tommy Kawagoa. Choose one or the other. Nobody calls him Thomas Tommy Kawagoa. And that's what you're doing if you put 10 to the minus 9 nanoliters. So you're putting the nickname and the given name together. Does that help? So we want the prefix on one side, what it means on the other. This is not the advanced method, but this is what I'm going to show you. Okay. I really need to bring my calculator. Maybe I'll go up and get it during the break. 3.88 EE12. You have to use scientific notation on this one because the number's too big. Times 1 EE 9 minus divided by 3.785 equals, and my calculator is showing me 1025.099, and it goes on and on and on. And that would be gallons. Did other people get the same number? Yes? Okay, I hear more yeses than nos. Sigfigs, how many? Question?
It's supposed to be 3.785 gallons a liter?
We're going to go with what we were given. Since we were given that, we're going to use it. Yes, there are more digits after that that are known, but if they weren't given to us, we're not going to use them. And that's another reason to show your work, because we're going to write down the actual one that we used. And so if you're doing it, for homework and you have a more precise unit equation, you can definitely use that, but then write that down here as well. The difference should only be in the uncertain digit. But how many sig figs should this answer have? I hear 3 and 4. 3. Why 3? Because what we started with only had 3. We don't have to think about this one. This one has 4, but we only started with 3. So we're going to have to round that 2 up to a 3. And the best answer is 1.03 times 10 to the third gallons. An acceptable answer would be 1030 gallons. Any questions?
I keep getting like the decimal point 1 behind it. So I get
That's an issue with the EE button on your calculator. So come see me during the break, and I'll tell your calculator what's what, and we'll get it straightened out. Yeah, if you're getting this number, but the decimal point is in a different place, so you end up with a different exponent up here, it's because there's an issue with how you and your calculator are communicating. And that's important to recognize and get straightened out. Any other questions? Yes?
yeah, after the end of my answer, I got 0.75.
Yeah, it keeps going on. I ended it there because I was tired of writing digits. I'm looking over here and I'm thinking, yeah, that's already too many, and so it doesn't really matter. Mine actually went on, it's 1025.0990752972226. So lots of digits, just because of the way my calculator is. There's a moth flying around. Any other questions? We need a break. And I don't think are you guys feeling pretty okay with this whole unit analysis thing? Yeah? Okay, so I'm not going to do this example, and we're going to pause right here and take a break. Compound units. Some measurements have ratios of units, and this would be things like a speed, like the speed limit on the highway is 55 miles per hour. This is a ratio of units, miles per hour. How do we convert this? What if we want meters per second? Well, we're going to do each unit separately. So 55 miles per hour. First, we're going to convert miles to meters. And then we're going to convert hours to seconds. Or maybe we need to convert hours to minutes and then to seconds. When you're converting the unit that's in the denominator, these guys are going to look upside down of what we regularly do. What we want hours to cancel out, so hours comes to the top. We would put minutes in the bottom because we know the relationship. And then we put minutes in the top and seconds in the bottom. The minutes cancel, the hours cancel, and what unit are we left with? We've got meters on the top and seconds on the bottom. So you get meters per second is the unit. I'm not going to do all the numbers. So let's do a real example. A motorcycle is traveling at 75 kilometers per hour. What is the speed in meters per second? So let's think of our path here. We want meters per second. Write that as a vertical fraction. This is a horizontal fraction, kilometers per hour. Sometimes we don't recognize, oh, that's a fraction. We want to know that this is a fraction. So what we're starting with is 75 kilometers per hour. This line goes all the way under the number. So we can convert kilometers directly to meters, right? So we can go kilometers to meters. Hours, we may want to go to minutes in the middle, and from minutes to seconds. There's actually going to be 3 factors. There's 3 arrows. We're going to have 3 factors. 75 kilometers per hour. I have 3 fractions. It's not a good X. Here we've got, and maybe it will help if we think of that this is the fraction line. It's a very bad dotted line. But this is a fraction. There's a unit on the top, and that's what this unit is doing. And there's a unit in the denominator, and these changes are happening in the denominator. So we have like 2 different paths kind of at the same time. So this path is kilometers to meters. Let's do that one first. Kilometers to meters. And then I'll put kilometers down here and have those cancel out. Just occurs to me this would be a great time for the use of color. So we're going to have this. The denominator is going to be green. To seconds. So here's our denominator unit. So we did the first one. This path, hours to minutes to seconds, is going to happen in the denominator because that's where hours is. So hours, we got to skip that one because that one's full. Hours to minutes to seconds. So put minutes in here and seconds over there. It's upside down. It is. We need hours to cancel. So this time it's going to go into the top to cancel. Hours cancel. And we need to get rid of these minutes. So if we put minute up there, the minutes cancel out. Any questions about how I got the units in there? Now we need numbers. Let's start at the end here. Minutes and seconds, what's the relationship? 1 minute is 60 seconds. How about between hours and minutes? 1 hour is 60 minutes. And how about kilometers to meters? Yeah, kilo means 10 to the third. Kilo's in the bottom. This is like Tommy Kawagoa. So up here I'm going to put the full name, the full meaning. 10 to the third. So this is Thomas Kawagoa. That's the same person as Tommy Kawagoa. He just is going by his nickname. And that's all this is. This is the real thing, and this is the nickname for it. So we've got my calculator now. 75 times 10 to the third times 1 EE3 divided by 60 equals, calculator says 20.83333, that's just going to repeat forever, meters per second. I'm going to look through the numerator after I plug in my computer. Power has been restored. I'm looking for the units. This is the number, a unit in the numerator that has not canceled out, and in the bottom, it's this one. So I have meters per second. How many sigfigs should I have? 2. This is exact, this is exact, this is exact, within the same system. So starting with 2, we should end up with 2. So this will be 21 meters per second. Any questions? You want to see another one with compound units? This means yes. This means no. And he's doing this. Okay, we'll do this one too. Bromine has a density of 3.12 grams per milliliter. What is the density in pounds per gallon? And we're given some information here. What are we looking for? Pounds per gallon. So I'm going to write that down over on the right side. Pounds per gallon. And what are we starting with? 3.12 grams per milliliter. So let's just extend this line all the way across. Grams to pounds. Can I do that in one step? Yeah, I've got a relationship between pounds and grams. Somebody pressed the easy button. Love the easy button. Should have written these in a different color, but I didn't, so I'll do that same messy thing down here. We've got milliliters to gallons that we're looking to do in the denominator. Here we have a relationship between gallons and liters. So if we put liters here in the middle, we could use that relationship to get to gallons, and then this is a matter of knowing the prefix. So I'm going to start with 3.12 grams per milliliter. I'm just going to do the numerator first because that's kind of how I think. So here I'm going to do, I'm wanting pounds in the numerator and grams in the denominator. And I'm going to look over here and see I've got 1 pound and 454 grams. So there, I'm done with the top. The bottom has 2 arrows, so I've got 2 more unit factors. Milliliters to liters to gallons. Milliliter is in the denominator. I should have made him green. So I'm going to follow this path underground. Maybe Dora is digging a tunnel. That's what she's doing. This is what's going on above the ground, and then Boots is underground in the tunnel. Do you like that? No? It's okay to laugh at me. Yeah, you should laugh at me. I'm ridiculous. That's what happens when you have too many children and you get old and tired. And you...
that in a really, really bad way. There's no reason my monkey should be getting comments.
Well, that's true. Monkeys should not be digging tunnels. But monkeys should not be wearing boots either.
Neither should cats.
Neither should
But they
cats.
do.
Yes. So there's all sorts of, it's actually kind of amusing as a parent to sit with your child and watch their cartoons and just, it's not polite to do this out loud, but just to mentally pick it apart and just point out all the physics violations and just the impossibilities. You have to amuse yourself somehow when you're watching Dora the Explorer. Okay, we'll get back to this. Anyway, so Boots is tunneling underground for no good reason. Milliliters to liters to gallons. Milliliters to liters to gallons. Everything here is upside down. Maybe it's an alternate universe. I don't know. We want to cancel milliliters. It's in the bottom here. We need to put it in the top. Because you get one thing in the top and the same thing in the bottom, you can cross them off. And then we need to get rid of liters, so we put liters up here. The liters cancel out. Okay? We got our units for that guy. Now we need numbers. Here we've got 1 gallon, 3.785 liters. So down here, 1 gallon is 3.785 liters. Milliliters to liters. Milli means 10 to the minus 3. So we'll put 10 to the minus 3 in here. Those conversions are getting easier, aren't they? You just need to know what M stands for, and you write it on the other side, and you're good. Okay, so 3.12. We're going to divide by 454, and I'm going to divide by 1 EE minus 3, and then I'm going to multiply by 3.785 equals, and this equals 26.01145,374. If I write everything out. And what is the unit there? What?
Pounds over gallon.
Pounds over gallons. I've got pounds left and gallons. So this is pounds per gallon. How many significant figures? Should be 3. This one has 3. Where's my arrow? There it is. 3. This one has 3. That's exact. And this one has 4. So 3 would give us 26.0 pounds per gallon. Any questions? Once you learn how to do stuff like this, you can figure out how much Tylenol to give your baby just based on all the stuff they write on the bottle. Yes?
Yeah, for instance, we just have to put the number answer, or do we have to say bromine as it into the 26.0 pounds per gallon?
That's a good question. Is this acceptable as the answer, or do we have to make a sentence out of it? This is chemistry, not English class. So I just want to see the number with the unit, and especially, sometimes things get kind of messy here and it's not really obvious what our final answer is. A box around your answer is always a good idea. Now, on the exams, it'll be multiple choice. So then you don't even have to worry about that. But on the worksheets, yeah, you don't need to make a sentence out of it. Any other questions? Chemists like to use phrases a lot, not complete sentences. We know the difference, but more with the units. Units raised to a power. These are fun. Sometimes we run into units that are squared or cubed, things like feet squared or cubic centimeters, and we have to convert those. Then we have to cube or square the conversion factor also. And this part is really, really important. Both the numerical values and the units must be cubed. Okay? So let's do an example here. How many cubic feet are in 14.5 cubic yards? Well, we want cubic feet, and we have 14.5 cubic yards. Do we know the relationship between yards and feet? Yes. So that means we can do this essentially in one step. Because we need to know the relationship between the unit without the power, and then we'll be fine. So 14.5 yards cubed. I'm going to put feet in the numerator and yards in the denominator. And the relationship is 3 feet to 1 yard. Now, does yards cubed cancel with yard? No. I need yards cubed. If I'm going to cube part of this, I have to cube the whole thing in order for it to stay equal. Remember, this is a unit factor. The top equals the bottom. So what I'm going to do is I'm going to cube, I almost said square, I'm going to cube the whole thing. What that means is this cube applies to everything in here, the numbers and the units. So I'm going to just kind of expand this. So that is 3 cubed feet cubed per 1 cubed yard cubed. The cubic yards cancel out. What is 1 cubed? 1. Okay, so he can go away too. What's 3 cubed? 27. 3 times 3 is 9, times 3 is 27. Or you can use the x cubed button on your calculator. So we've got 14.5 times 27. And I did not leave any room. 391.5 cubic feet is what the calculator tells me. How many sigfigs should that have? 3. Our starting number had 3. This is exact. We don't need to worry about it. So we should round this to 392 cubic feet. How do you feel about that? Blank stares is how you feel about it. Fine. Let's think about this for a minute, okay? I'll draw you a picture. I'm not an artist, but I can draw a reasonable cube. So here's a cube. And we're measuring the side, and the side is 3 feet. And this side is 3 feet. And this dimension is 3 feet. What's the volume of that cube? Length times width times height is going to be 27 cubic feet, right? What if I measure it using yards? This is 1 yard, and this is 1 yard, and this is 1 yard. What's the volume in yards? 1 cubic yard. 1 yard equals 3 feet. 1 cubic yard does not equal 3 cubic feet. The 3 has to be cubed as well. Okay? We are running out of time. Let's just do one of these. Let's do the bottom one, the tire pressure one. So, automobile tire has a pressure of 32 psi. PSI stands for pounds per square inch. That's what PSI comes from. What's the pressure in grams? Grams per square centimeter. I just had this brain fart and thought it was supposed to be cubed, but that would be ridiculous. So what are we looking for, unit-wise? Grams per square centimeter, right? And we're starting with 32 pounds per square inch. So we need to convert the numerator and the denominator and think about them separately. Can we go from pounds to grams? Yeah, we can, because they gave us this. How about inches to centimeters? Is there a relationship between inches and centimeters?
Yes.
Yeah, there is. So that's also 1. I need more space, so I'm going to make more space. Bye-bye. Oh, might as well erase him too. So we're going to come up here, because we can. 32 pounds per square inch. Let's do the numerator first. Pounds to grams. Divide by pounds. Units cancel out. 1 pound, 454 grams. From this relationship that we were given. Now let's do the denominator. So it was inches squared to centimeters squared. So we're going to put centimeters here, and then we need inches on top. And then we need to put the relationship in. 1 inch is 2.54 centimeters. Inches don't cancel inches squared. We need to square this. And then the units are going to cancel out. So how do you do this on your calculator without writing junk down? 32 times 454 divided by, now remember we have to square the number, divided by 2.54, and then I'm going to press the x squared button. It'll square it for me, and I press equals. And how many sig figs should my answer have? Should have 2. The number's really big though. It's 2251.8 blah blah blah. That's more than 2. And the units are going to be grams per square centimeter. I want to keep 2. So best idea is to put it in scientific notation. I need to round that 2 up to a 3 though. I'm keeping the 2, but this one's 5 or greater, so I round up to 3. 2.3 times 10 to the 3rd grams per cubic centimeter. Square centimeter. Square centimeter. Any questions? I got some head shaking that time. That was good. That's called feedback.